So we are continuing to talk and work through some factoring. And in the last little lesson, I said there are the two key questions you ask. And once you answer those questions, then you're able to factor. And the first question was, is there a GCF or a greatest common factor? And we did a few examples. And then the second question, which I'll write again here, the second question, basically you're asking how many terms there are. And there's going to be three possibilities. You can have 2 terms, 3 terms, or 4 terms. And actually, they give these a special name. 2 terms, you'll oftentimes hear me say, or others call these binomials. That means like it's a polynomial with 2 terms, the bi meaning 2, like bicycle. For 3 terms, so like tricycle, I like to call it a trinomial. And then you'll be glad to know with 4 terms, there's no special name. They just call it a 4-term polynomial. So once you see how many terms there are, that tells you what you're going to try. So let's first look at the case where we have 2 terms. If you have 2 terms, there are 2 things you can try. The first is called difference of squares. And the second thing you can try in terms of factoring are sum or difference of cubes. So whenever you have 2 terms you're trying to factor, you can try difference of squares or you can try sum or difference of cubes. And let me make a note now. Oftentimes, you are not able to factor expressions. Sometimes you will have an expression with 2 terms and you try to factor it using difference of squares. That doesn't quite work. So you go and try sum or difference of cubes, and that doesn't work. Sometimes it's just the case that nothing works, it cannot be factored, and if it can't be factored, in the math world, they like to call it prime, meaning it can't be factored. Nothing can be done with it. So let's take a minute and actually we're going to first, for the rest of this little lesson, we're going to look at the case of difference of squares. So let me tell you how to check to see if it's a difference of squares and then quickly do some examples. So here's a binomial. There is no GCF. So now I'm going to try and factor. And I'm going to try to use difference of squares. Difference of squares, you have 3 things to check. And if these 3 things are true, then you can factor by difference of squares. The first thing is, it has to be a minus sign. If it's not a minus sign there, then it is not a difference of squares. Hence, that's where the word difference comes from. It has to be a difference. Difference means subtraction. So that's the first thing we check. And then we go and I look at my first term and I ask myself the question, is there something that I can square that ends up equaling x squared? This is a pretty simple question for this problem. Can I square something and have it equal x squared? Yeah, well, obviously x, right? If you square x, you get x squared. So there's the second thing I check to see if it's true. And then the third thing is I look at my second term and I ask the same question. Is there something I can square that will equal my second term? And in this case, it's 3. And that's my third thing to check. So basically, 3 things to check. If it's a minus sign, if you can square something to equal the first term, if you can square something to equal the last term, if those 3 things are true, you have a difference of squares, and then it's pretty easy to write down what it is when you factor it. You simply take the first factor and you add to it the second factor, so x plus 3. You put it in parentheses, and you take the same 2 factors. Instead of adding them, you subtract them. So x squared minus 9 equals x plus 3 times x minus 3. If you would take the time to go ahead and multiply out those 2 parentheses, it would equal x squared minus 9. So that's factoring by difference of squares. And let me just do a couple more quick examples. Once you get the hang of it, it's not very difficult. How about 16 minus 25y squared? Now you notice whenever I do problems with factoring, I'm always going to remind you to check the GCF. It's important, it's essential, you always check the GCF. So here, 16 minus 25y squared, is there a GCF? Is there a number or a variable in common? Turns out there's not. Okay, so the second question is how many terms are there? There are 2 terms. I'm going to try difference of squares. Now notice I do have a subtract. Up here I notice if I square 4, that equals 16. And if I square 5y, that equals 25y squared. Lo and behold, I do have a difference of squares. And it's 4 plus 5y times 4 minus 5y. All right, 3 more very quick examples, just to give you lots of practice. How about this one? X squared plus 4. There is no GCF. I have 2 terms. Let's try difference of squares. Since we have a binomial, what do you think? Some students will try and factor this. But what's the first thing you need to check for difference of squares? It has to be a subtract. Look here. It's addition. Nothing I can do. I'm stuck. It's not going to be difference of squares. So this is prime. Nothing I can do. All right. That maybe was a little bit of a trick question. Here's another one. 2x squared minus 200. We're asked to factor this. What's the first thing you do? Well, you know what? If you forget to check the GCF, let's see what would happen. Say you forgot to check the GCF, and you just said, here's 2 terms, let's try difference of squares, and you notice we've got subtract here, and then you look at 2x squared, and you say, can I square something and get 2x squared? And then you say, no, and then maybe you would think this is prime. Well, the whole key is you forgot to factor out the GCF. Do not forget the GCF. If we look here, I've got 2x squared and 200. I've got 2 and 200. There's a GCF of 2, which I can pull it out. And then I have x squared minus 100. So once you pull out the GCF, then you look inside the parentheses and see how many terms there are and see if you can factor. Now, hopefully by now you're getting pretty good and you realize this is a difference of squares. I've got to subtract of x x here and 10 here. So I have 2 times x plus 10, x minus 10. And then the very last one, x to the 4th minus 16. Is there a GCF? No, there is not. How many terms? There are 2 terms. Let's try difference of squares. Turns out, first of all, I've got a minus. Now, can I square something and have it equal x to the 4th? I can. If you square x squared, it's x to the 4th. And then the 16 is just 4 squared. So it's a difference of squares. And you get x squared plus 4 times x squared minus 4. Now, oftentimes, you think you're done, but even when you factor, you still have to go in to the parentheses that you just wrote and make sure nothing else factors. Well, here, the first parentheses, x squared plus 4, it's a binomial. I could try difference of squares, but right away I notice I've got a plus here, so it's not difference of squares. So the x squared plus 4 doesn't factor. However, look at this second parenthesis. X squared minus 4. It's also a binomial. And it looks like it is, in fact, a difference of squares. Because if you square x and you square 2, you get x squared minus 4, and then it is a minus. So what we finally have is the x squared plus 4 just stays here. And then this second parenthesis breaks up into x plus 2 times x minus 2. So those are a few examples of difference of squares.